Hello, I'm Robert, fact checker and science blogger, and helping people who are scared of many things. And this time, it's about asteroids, and why you don't need to be scared of asteroids. They're far less scary than lightning. So, my short summary is that the risk from the larger asteroids from 1 kilometre upwards is pretty much retired. And there's still a risk from smaller asteroids, but we can deflect most of them, or if necessary, we can evacuate the area. That we can show from hurricanes that we can evacuate a region given just a couple of days warning, sometimes very fast evacuations. But it's not likely at all. If you think about it, in all of previous history, we have never had, we've had volcanic eruptions like Vesuvius, we've had earthquakes, we've had tsunamis, we've had hurricanes. There have been many things that have devastated cities. There's never once in all of human history been a single asteroid that has devastated a city. So you can see that city killer asteroids are very rare indeed. And so it's good that we're looking out for them, but you don't need to think that, oh, this is something that's very likely to happen at all. It's extremely unlikely. And we'll find out part of that reason is that only 1% of the Earth's surface is urban. So I talked about in my most likely future thing that we're going to predict will be a splosh in the ocean. So I did a video about that, so I won't talk about that again here. I'll put a link in the video description to the previous video about that. Oh yes, there we are. I've got a link to the article there, and I've already talked about that. But given the extremely unlikely nature of such collisions, almost all of these predictions will turn out to be false alarms. And if it is verified to be an Earth colliding trajectory, it seems likely that this collision possibility will be known several years prior to the actual event. Given several years warning time, existing technology could be used to deflect the threatening object away from Earth. So that is the Center for Near-Earth Object Studies, which is it's funded by the United States government, and there are several of these organizations around the world, like the Minor Planet Center, for instance, but the Center for Near-Earth Object Studies has the most advanced predictions of all of them. It takes account of all sorts of very minute effects, and it's the best one for predicting the right through past numerous flybys right into the future, right to 2100 and beyond. So they're the go-to site for this sort of thing, but don't feel that they're the only ones. There are plenty of others keeping an eye on it as well. It's just these two are the very best calculations of all of them. So they're highly respected on this topic. And so over long periods of time, and the threat to any one person from auto accidents, disease, other natural disasters, and a variety of other problems is much higher than the threat from NEOs, near-Earth objects. But over long periods of time, they're not negligible, the effects of Earth being impacted, and so we have to look at this. And originally, when this study started, then they didn't know what we now know, that they've now surveyed nearly all the 1 kilometre ones, and we now know all the ones of 10 kilometres and larger. All this was triggered back in whenever it was, when Schumacher-Levy comet hit Jupiter in the late 20th century. Then this led to people realizing, oh, something could hit Earth. And it's a big comet. It was quite an impressive thing when it hit Jupiter and left lots of marks on the surface of Jupiter that gradually faded away. And it was really quite an exciting astronomical event. And then it got people thinking, could this happen to Earth? And so after that, until then, we had only rather sporadic detection of asteroids. People weren't particularly looking out for them. Amateurs quite often discovered asteroids before then, which gives you an idea of how we weren't that thorough. But now there's a very advanced automated, every night there are these big telescopes searching for asteroids, and that's why we discovered so many, and that's why there's so many asteroids flying past. It's not that there are more flying past now than there were, the reason is that we are looking for them and we can now spot them. And it's got to the point where amateurs never discover new asteroids. I don't think there's been a recent case of an amateur discovering a new asteroid, especially not with their home telescopes. They do still discover comets, because the human eye is better than a computer at spotting the fuzzy comet and recognizing it's a comet, not just a smudge. And so you do get amateurs searching through these images to look for asteroids and finding the occasional comet, but that's about it now. Without amateurs, very or you do get some that do. Yes, we do get some amateurs detect as very faint asteroids. Actually, there has been an example. Let me just pause a minute. Yes, here goes. It was an amateur in Brazil who discovered a 1 kilometer wide asteroid. Now it's a very distant one. You see it's way out around the orbit of Mars, very, very far from Earth. But really quite interesting. The reason he did it, he managed to find it, was because he's in the southern hemisphere, and most of the really good asteroid detection telescopes are in the northern hemisphere. They have quite a lot of overlap into the southern hemisphere, but they don't kind of see very far into the south. And this doesn't mean that we can miss many asteroids. This was in that direction, but we've still got a little bit of a gap in that direction. The 1 kilometer ones that are of interest to Earth, where we eventually will find, most of them are actually probably ones that actually do flybys of Earth, and they're most likely hiding behind the sun, the ones we haven't seen yet. The one that was flying up there that actually does a close flyby of Earth, and you'd likely, it's got a very long orbit and very far away and far beyond Mars. And but anyway, this is his telescope, and he must have been quite exciting for an amateur to discover an asteroid nowadays. It's very rare to discover an asteroid nowadays as an amateur, because and as you say here, we hear more and more about asteroid discoveries. That's because we're getting better at finding and tracking them near Earth. There aren't suddenly more asteroids, we're just getting better at seeing them. And his an outline time. 90% of objects of at least a kilometre wide have already been found, and none will hurt Earth anytime soon. That's talking about near-Earth objects, so I assume this one was just close enough to be a near-Earth object. This is that's the discovery image. That's how he discovered it. And so there's these are various. Yes, I'll talk about all that in a minute. That sort of thing. So there's big developments coming. It's going to be quite difficult to discover something even in the southern hemisphere by the mid-2020s, because we've got big telescope. We've also got the yes. I'll just pause and stop and check another thing. Yes, the Vera Rubin Observatory, the biggest telescope devoted to this by far, is in sometime 2022. And that's going to be in Chile, which is 30 degrees south. So after that one is constructed, we'll have a very, very good view of the southern sky as well. And this is the one. And this can see 4 times deeper than any of the other ones. This is an artist's impression of it. And very high in the mountains in Chile. And this will be able to see 64 times the search volume, 4 times the depth of anything previously to that. So that's going to make a huge difference to discovering these things in the future. So anyway, yes, so we do still discover these things, but we know that was quite a remarkable thing for an amateur to discover 1 kilometer one. We found nearly all the 1 kilometer ones that come anywhere near Earth, and only a few % of those left. Of all the ones of 1 kilometer in diameter, then we know of only one that's got a very remote chance expected to miss in 2880, so 4 centuries from now. And then I said before, I said in my previous video, you probably know if you've watched that, so try and think how long ago do you think it was last time we had a 1 kilometre impact? And that gives you an idea. Probably, I mean, roughly the same sort of order of time for the future. And the answer is, it's 700,000 years ago. And so we can expect a few 100,000 years before the next one of a 1 kilometre size. And the long period comets, then they're exceedingly rare. They've got all the near Earth objects of 10 kilometres and larger. And so if there is a 1 kilometre one that we haven't discovered yet, then it's almost certainly, it may be just behind the Sun. There are a few we haven't discovered yet, maybe just behind the Sun and gradually peek into view. Could possibly be missing somewhere in the Southern Hemisphere. In that gap then, it'll be discovered pretty quickly after we build the Vera Rubin Observatory. They'll do a complete sky map in 3 days. So in the first 3 days of observation of the Vera Rubin Observatory, then they will see everything you can see at that particular time of year from that particular observatory. And that will hugely expand the number that we know about in just 3 days. Because they're looking deeper than any telescope has looked before. So maybe they'll find a kilometre one then the entire year round, because there's a tiny gap around the Sun that they can't see, and then a few months later they'll be able to see into that gap. And so it won't take long to really expand and find many of the missing ones if they're being missed just by being a little bit further away and not seen by the other telescopes. And then we've got lots of other telescopes. That we've got the Fly Eye from ESA, which is going to be deployed all around the world, and that'll be that's for detecting ones that are approaching Earth. So you want to look at as much of the sky as quickly as possible, and once they're going doing close flybys, because even 3 nights, if it's flying past quite close, then you could easily fall into a gap in all our telescopes, even the Vera Rubin Observatory with 3 nights, and most is longer than that, quite a lot longer than that. It takes to survey the entire sky. So you can get asteroid that is very small, especially, and flies close by. It can go through those gaps. And we've got the Atlas telescope, and that does a very quick survey of the entire sky, but at a lower resolution than the Vera Rubin one. And that one is optimized to spot these ones as they approach Earth. So we see most of those. We can see most of the majority, even of quite small ones, we'll spot in advance. It'll spot it some days in advance, and unless it's very small, a week in advance or more. And so we have lots of warning. For most of them, we can still have the possibility, but it's greatly reduced, of being surprised from the direction of the Sun, where we have nothing. If it's coming to us almost directly from the Sun's side, which is a few degrees to 20 degrees or so to the left or right of the Sun, or around the Sun, then none of our telescopes can look that way. And so we do still have a gap there, and we have a larger gap for the smaller telescopes, smaller asteroids, because of if it's so small you can't see it. So we can't see, it's very hard to spot a fireball in advance, because that's so small, and there's nothing can look in the direction of the Sun, because we're close enough to the Sun to spot a fireball. So if it's on the day side it approaches from. So and then as it gets bigger, then it's easier to spot, even if the Sun's sky is quite light, and also more likely to spot it in advance in a previous flyby. So anyway, we don't, 95%, I think it's gone up a bit since I wrote that. Long period comets are exceedingly rare. None come as close as the Moon, and several times that distance 1770, but all the recent ones at vast distances, far further away even than that. But while we have any near-Earth objects, often come closer than the Moon. So you can see how rare long period comets are. There's nothing to need to be worried about. We know all the big ones. We have telescopes now that can spot a 1 kilometre one long in advance. It almost, I just say, in any direction, or almost always. I get asked to, I must be careful to qualify this. We don't have total certainty, but it's just absolutely, we can expect, be very surprising if we get 1 kilometre one we don't spot months and most likely centuries in advance. And decades would be, you'd be very surprised if it was as short a time scale as decades that we spotted in advance. and even given a few years of warning at 1 kilometre size, we can deflect it, and if not, then we can mitigate and evacuate, and nobody needs to die even at that size if we know where it's going to hit in advance, and if people are carefully organised in what we do in responding to it. So and then especially the small ones, and the so you move images of people in the city. You always get these things in these devastating movies where you probably some of them seen them and some people have been quite traumatized by and then you read these asteroid stories and you imagine a great tsunami approaching a city and people running away and the tsunami knocking down buildings around them and cars flying around in the water and so on. That just can't happen, because if you have something big like that, like the sort of thing they imagine, and some of them are just impossible, like Armageddon, that's ridiculous. That's like Ceres, the biggest thing in the asteroid belt hitting Earth. But got something big like that, then you're going to be tracking it for years or decades probably, and then you'll know exactly where it's going to hit, and then you'll, if you can't deflect it, and of course we would deflect it, but if for some reason you can't, then they're certainly not going to be sitting in, going around doing their everyday business in New York. They'd be up in the hills nearby, have evacuated all their precious possessions, got a disaster plan ready to rebuild New York after the tsunami and so on. But that of course doesn't make such an exciting movie, but that's much more realistic. And for the tsunami ones, the smaller ones, so the people do occasionally die of these smaller ones. But it's such an uncommon death, and it's very rare it happens. There's one from Indiana in 19th century was a hoax. None in the US. One in the US has a very, very serious bruise on her thigh and needed medical attention in a hospital, I believe. It was really quite badly affected by that, serious impact on her health. But that's the worst that has ever happened to anyone. And that was, so that's one person in the entire United States, in the entire recorded history of the United States. So it's very rare to be badly affected by asteroids. And worldwide there have been a handful of people who have died in the 20th century of asteroids. If you really research into this, you get people saying nobody's died of it. It's not true. 3 people died in 1908, reindeer herders in a remote part of Siberia. And we might well have been able to warn with modern technology and said, don't herd your reindeer in this area because a big asteroid's going to hit. It could be moderately sized, could be quite large, big enough to be really quite devastating. And lots of the reindeer were killed, and 3 of the reindeer herders. And there's a hamlet of 14 in Mexico, so also in the 20th century. So, and the other occasional examples from previous centuries, which are less well documented, but some of them are pretty clear, were deaths by asteroid. So it does happen, but bear in mind, as I explained in the previous video, that in 2,000 years, then, the year 2000 is the last time that there was a death by hailstone in the United States. So death by hailstone is much more common than death from a meteorite, and that's an exceedingly rare death. And death by lightning, you get 20 a year in the United States. So on a personal level, personal risk, it's really something you not just to forget about. Think about your personal health and about traffic accidents. Don't worry about asteroids. So large ones up to a kilometre, even up to around a kilometre, there are no global effects, but of course can be devastating locally. Up to 100 metres in diameter, it could produce a tsunami at that size, but it wouldn't travel so far as the tsunamis that you get from earthquakes. And that's how I explained there, because if they'd have to hit very close to the shore, because they produce a kind of tsunami that almost cancels itself out as soon as it happens. by filling in the gap in the sea that it creates. The sea rushes back in. And also the wavelength is much smaller than an earthquake one, so it travels, it splashes out very quickly. I explained that in the previous video. So at 1.3 kilometers, 1950 DA, you can have, at that size, you could have a dimming of just some dust in the atmosphere, enough to cool it down slightly by a few degrees for a few weeks. If you had something like that, good impact on some crops. And that's the one. It's got 1 chance in 8,300. That means it's 99.988% certain it misses. We've got 860 years to study it and do something about it in that very remote chance. And but normally they're removed. Right. And these are all the ones of 10 kilometers and larger. This is the only one that is a near future, and near means 2,000 years from now, more than that. But it's a million times more likely to miss than to hit on that date. But if on that date 4,479 or something like that, on that date, then if there's only one place, one time that it could intersect with Earth's orbit, but it's expected to miss. But we have thousands of years to prepare for it. Put a post-it note on your kitchen wall for 4,479. If your house is still surviving, then remind them to keep an eye out for this. I'm just joking. They will for sure be keeping an eye out on that in that very remote chance. So that's Comet Swift Tuttle 4479. I got it right. This would really be a biggie, but we haven't had an impact that size for over 3 billion years. I expect it to miss. That's very, very rare. So something this big, 26 kilometers. So that is, it is possible to have a really big impact like that. As I say, could boil the oceans. So but that's not something that's happened for 3 billion years. So it's certainly we need to keep an eye on everything, but there's nothing that big that is close to us there's any risk of doing that, except this particular asteroid, particular comet. And it's 1,000,000 to 1, which means that typically, and by the year 2000, 2000 years from now, so multiply two, so that's like, it's not surprising that we haven't had an impact that big for 3 billion years. Your expected wait time for something that big is of the order of many billions of years. So in the long period ones, I say 1.3 million years from now, the Glycus 710 will pass by our solar system way beyond. And so when I said ocean boiling, it's just the surface of the ocean. In case that's any hope, in case that's any comfort, but we could certainly deflect it. And don't worry about our descendants, even in that very, 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 very remote possibility, because they will be able to deflect it. And indeed, I would expect that by the end of, just by the middle of this century, remember we're already safer than any previous century, and by the end of this century, then, or even the middle of this century, I expect we know just about all, even the very small asteroids, because things are developing so fast, faster than predicted. We can't really predict how fast it's going to go. We're going to be able to put huge things into orbit probably by 2030. We'll be able to put enormous telescopes into orbit, and from orbit you can see things much more easily. And we could do it right now. So I'm just going to talk. I think I talked about that in the last one, so maybe I shouldn't give too much on that. Yes, so we've got methods of deflecting comets. This is about potentially hazardous asteroids, and so you keep on getting that. The classification of an object as potentially hazardous means that there's a few % possibility they could hit Earth over the next 20 million years. So it's the time scale that the when you get these sensationalist articles about potentially hazardous asteroid, they are potentially hazardous, but what they miss out is the time scale. They're potentially hazardous over 20 million years, and some of them are, you can even know, even though they've got the PHA classification because of a certain set of criteria which leads to you calling it a potentially hazardous asteroid, but some of those things that fit those criteria just can't hit us, even over 20 million years. So it's a first classification in order to try to kind of catch within it all the ones that, or nearly all the ones that have a chance of hitting us in 20 million years, and then within that you will find eventually, so you'll find with a bit more investigation that some of them can never hit us, and then within us you'll find a few more that come very close by, and then you look at those even more closely, then you find the near Earth objects, and then you get the ones that you're really interested in. So when you get an article saying, oh, this is a potentially hazardous asteroid and it's a very serious thing, it's not. It's just a preliminary classification that is useful to astronomers in order to narrow down and find things that are really of interest. PHAs themselves are not generally of interest for being a risk to Earth, but some of them are, so you've got to check them. And then another thing, you get these people saying, oh, if this asteroid flies past, then it's going to do something, cause earthquakes or something. This is not true. The moon is, it's got to look as big as the moon in the sky to have the same tidal effect as the moon. And these, and the same density. If you've got a density and the visual and the apparent diameter, then that gives you the amount of the tides. So it would be the same, or if it's less dense than the moon, it would have to be even larger than the moon in size. Most asteroids would be less dense than the moon. So it's not going to have as much tidal effect as the moon, unless it's so big in your sky, it's actually larger than the moon in your sky, if it's an asteroid. And none of them, even the biggest asteroids, even a 10-kilometer asteroid, is going to be flying past too far away to do anything gravitational. Even a close flyby one of those is not going to do anything tidal of any that you're ever going to notice. So so if an asteroid misses Earth, it doesn't matter if it misses by 100 kilometers, just skimming above the atmosphere, or 1,000,000 kilometers, a miss is a miss. So, and an example, if your car crosses a railway track on a bridge, then sometimes it might happen that you cross the railway track at the very moment the train passes by underneath, but you never have even a moment of concern about the train, because you're on a bridge and the train is on the track. And even though you're just 2 meters above it, say, when you're driving over the bridge, there's still zero risk of you being hit by the train. Even, if you looked at it, so if you might think, oh, if you told someone, well, most days I'm a kilometer away from the train when I cross the track, and some days I'm 100 meters away, and some days I'm 10 meters away, and yesterday I was only 2 meters away from the train, as if at the very moment it passed by, and they might think, if they thought you were talking about the crossing, then they might think that's very scary. Then if you went on and said, but I was on a bridge, and the bridge went over the track, and they immediately think, what are you fussing about? It doesn't matter how close you are to the bridge, to the train, as long as you're on the bridge. So it's the same when you've got a close flyby of an asteroid. Just don't, for what I do just then, just don't worry about that. So now, if you go to the, I've actually made a new version, so I'll pop this up here, where have I got it? I'll pop up the, oh, we don't have a new tablet, just a minute. Yes, because of this privacy thing. I do this so as to not have, I'll just bring it up another window. I do this so as to not show notifications when I'm using Quora, and also to remove some of the header. Sometimes you get people's names show up. I'm not sure if it still does that. So anyway, so I've done that for privacy reasons. So anyway, this is my non-techie version. I'll put a link in the video description of the NASA Sentry Table, because the Sentry Table itself is very techie, and really you just take one look at this. And most people just take one look at that and they say, what's it mean by pre-infinity, H mag, year range, potential impacts? So that's what makes sense. But then look at potential impacts 1, or look at potential impacts, 78 potential impacts. You've got 101 potential impacts, and they find that very scary. And then they look at these other things, and this is supposed to tell you that it's not scary. And so you look at the Palermo scale and the Torino scale. Now the way you read this is that the Torino scale is no, that means it's no hazard. You should be looking at that last column there. Blue means it's so small that it's not a risk because it's so small, and 0 is no hazard. And then it's color coded, but it takes a little while to step around to discover that it is color coded. Show legend, click show legend, and then coloration, and then you look at the Torino scale, all colors. Then you've got to click through to the Torino scale, and then once you get to the Torino scale, because sometimes it'll turn green, you wonder what does green mean. You've got to go to legend, go to Torino scale, then you go down to Torino scale, and you look at green, and you see that green means normal. So that is quite a palaver, and most people don't go through any of that and don't understand that you need to do that. So my table simplifies it hugely. It's the same thing, but just instead of putting a 0, so to a mathematician or then this, they would bother by putting 2 words, no hazard. You could just have a simple 0, and everyone knows what the Torino scale means. This is what it means. So it just means no hazard. And so I've done this translation. I've removed all the columns that don't mean much to people. I've changed the Torino scale from 0 to no hazard. I put the actual diameter in an easier to understand form, and the name, and then you can click down, and if you want to, you can show a clickable name for harmless objects. You can put that in there, and you can have a look at, click at the things that are no hazard and find out about them. And so that's the 1950 DA that I was talking about. 2 later, so we're going to click down there to find out a far future possibility. Only date it could hit is 2008-80, and more nature, and the odds against a hit are 8,300 to 1 chance in 8,300 for a hit, and then if I've got a debunk, it links to the debunk. So I could maybe do a separate video about that, but just to give you a heads up that's there. And so is there anything else I haven't talked about? I think I've talked about the main things. I seem to have talked about the main things. It's quite a short article. In fact, I've said an awful lot more than there is in that article just by filling out some of the details. So hopefully this will help some of you who've got scared of asteroids to realise that it's not something to be scared of. As they say, that no one should be overly concerned about the impact of an asteroid or comet. The threat to any one person from auto accident, disease, other natural disasters, and a variety of other problems is much higher than the threats from NEOs. And then people that I talk to, they also feel scary, even if it's very unlikely. They don't have the mathematical idea of thinking about unlikeliness. They worry about the hugeness of the asteroids that they see in disaster movies, and that's just not going to happen. We can say there's a certainty above 10 kilometers, and above 1 kilometer, it's for practical purposes it's certain, because it's not really a realistic possibility. I think we've got to that point now. Maybe 5-10 years ago you could say it's a slight possibility. I'm talking about the way the ordinary person thinks about it, rather than the mathematician. I would say there's no realistic possibility that a 1 kilometer asteroid is going to surprise us, because as said, we found nearly all of them, and if there are any that we missed, it's extremely unlikely that there are any left that we have missed, and the most likely it's hundreds of thousands of years to the next one. If there is one that we've missed, then most likely it's behind the sun or in some other direction where if it's been behind, it could have been behind the sun for the last decade. If it's in an orbit that's almost 1 year, slightly less than 1 year, slightly above 1 year, then it'll just peek out behind it in one direction or the other. And one of the papers I read said that's the most likely place for undiscovered asteroids, and of the large ones. because as soon as they peek out from beyond the sun, then all our big telescopes will spot it within whenever they complete their cycle, whether it's a 1 week or whether it's a month or something. And even if it's in the southern hemisphere, it wouldn't spend that much time in the southern hemisphere. It can hide behind the sun in a 1 year orbit, because if it's close to 1 year, but if it's close to 1 year in the southern hemisphere, then a year later it's going to the northern hemisphere, so we spot it pretty easily. So it's not very easy to miss a big object in the southern hemisphere. We can miss smaller objects, or we can miss big ones if they're very distant and never come anywhere close to us. So it's really quite it's exceedingly unlikely that we have less than probably decades of warning, actually, and years surely. And I mean, in layman's terms, not as much speaking as a mathematician, where you talk about what's the probability that you dropped a packet of 5 pins and they all landed in a perfect tower head on top of each other, and you can work out a number for that, and they just start to stay balanced for 5 minutes before the whole thing collapses. I mean, you can work out the probabilities for most absurd things as a number, but I don't think you should really even think about it as a possibility in ordinary terms, that we're going to, only people think about it, that we'd be surprised by 1 kilometre asteroid. It's got to that point where we know nearly all of them, and the ones remaining are most likely. It'd be very surprising if there's even a small probability. Centuries in the future and decades in the future gets extremely unlikely indeed. And so most likely is, and by far the most likely next asteroid to hit Earth would be 20 to 50 kilometers in diameter, and the far most likely place it would hit is in the ocean, because most of the Earth's surface is ocean. And so if you ask someone to guess what is the most likely next NASA asteroid, so there's never been a NASA asteroid warning, and the most likely NASA asteroid warning that we will have one at some point, that's for sure. Whether it'll happen this century, almost certainly this, not certainly this century, but sometime, probably this century, next century, or the century after that, we're likely to have a warning of the equivalent of a city killer asteroid hitting Earth, and it would cause a small crater in a desert, or it would cause a explosion in an ocean. And I mean, it could be Chelyabinsk is our one for this century. It's not certain that we're going to have another Chelyabinsk this century, or Tunguska, even rare. That's more like several centuries anyway. So whenever we get our next one, and whether it be this century or the next century perhaps, whether it's our generation, the next generation, or the one after that, we are pretty certain to have one in the I would say, if you said the next 2-3 centuries, it's pretty certain we're going to have an asteroid warning. We are going to have one of something that is dangerous that hits the Earth. And the small ones, like the ones every century, once they're being able to predict even very, very small ones, then they can stop that 1 per century, a few per century ones that are just really quite small things, and a few bits fall, and like the lady whose thigh was damaged, then that wouldn't happen anymore. Eventually we'll get to that point. And the small hamlet in Mexico, and the 3 reindeer herders in Tunguska, and these sort of events, and they'll be able to stop those as well. And I think probably by the mid-century, start of mid to end of the century, we'll be going down and be discovering even the very small ones in advance. But if you talk about something as big as 1 kilometre, but even if you talk about so just put it in perspective, and if you're talking about one that could harm a city, then I have that in this page here, which I've already. I think that's so give you a bit more context of this one. That did you know? Click down here. Did you know that what if the Egyptians had developed asteroid detection telescopes, and it's supposed that they weren't that many steps in science away from what we have now. If they'd just been a little bit, had a few more gaps in their understanding, and then they could have started the Industrial Revolution and made their steam engines and eventually built their telescopes. If it had all started a few centuries, a few thousand years earlier, then because they're the same intelligence as us, and in fact there's no real reason. It could have been accelerated by several thousand years, who knows. Why did it take this particular length of time to get to the point where we are? So if we imagine the Egyptians, now this is not a good place for a telescope, that was just for a striking image, but suppose they had developed asteroid detection telescopes, then it would be a better place than the desert around, slightly, because it's raised up around the surroundings. Apart from that, it's not a sensible place. But their first telescopes might have been like that. Anyway, if they had developed asteroid detection telescopes, then they would still be waiting to warn for the first city killer impact. The city killer impact would not have happened yet. So it's important to put that in context. So the most likely next one, which may be this century, maybe next century, NASA will almost certainly will predict, or whatever, or space organization it is, if it's next century, then they almost certainly will predict, even certainly a couple of centuries, very unlikely that they don't predict something quite big, but most likely in a desert or ice sheet or in the ocean. And by quite big I mean 20 or 50 meters, enough to do a splosh, big splosh. Seawater goes up 100 meters or more, and or a small crater in a desert. Then small but significant, tens of meters across crater in the desert, and this we might get a prediction of that in the later this century, and that's far more likely than anything bigger than that. And there's never been anything. Even if the Homo erectus had somehow very quickly developed the ability 700,000 years ago, after their 1 kilometer asteroid they saw hit Earth, then they'd been waiting 700,000 years and still not found something as big as that. Although over those timescales they would see quite a few of the smaller ones, like the 20-50 meter ones, and a little bit larger they would see over that timescale. So, and it's good to work on methods of deflecting them, but it's exceedingly unlikely. That's more like thousands, tens of thousands of years that you're really thinking about if you've built up a system. So that's why it isn't really make good sense to build a specific deflection system for a specific type of asteroid, because your rockets are going to be sitting there waiting for thousands of years most likely, and then when you do get a scenario, it might be that whatever defense system you've developed for asteroids is not actually the one that's appropriate for the one you want to deflect. You might need to use something a bit different. So it's good to work out how you're going to do it, but it doesn't really make sense to develop an asteroid defense fleet, as it were. More think about how could we do it with our existing technology, how could we quickly adapt. For instance, the SpaceX's Falcon Heavy would be very useful for deflecting asteroids, because it can just bring a huge mass and send it up and get it to hit this asteroid, and doing several of those in the right way could deflect an asteroid. And so when they do the asteroid preparation exercise, they think about things like existing spacecraft, like the Falcon Heavy. They say, how many Falcon Heavies would we need to send to deflect this asteroid? So we already have the technology to deflect asteroids if we need to, but it's most likely we don't need those for maybe 1,000 years or more. If we're happy to just let it splosh into the ocean, or happy to let it just make a crater in a desert, and we don't try and deflect those away from Earth, then it could easily be thousands of years before we have an asteroid that it is actually worth deflecting. So again, it's actually headed for an urban area, and even then you could probably just deflect just a little bit if you had the accuracy by then, and say, well, actually it'd be quite fun, quite interesting to see, to actually watch an asteroid splosh into the ocean. So instead of deflecting it away from Earth, why just deflect it into the Pacific Ocean, and then we can do direct observation of the asteroid hitting the ocean and see what that does. So they might actually do that as well. I don't know if they will necessarily feel that it's incredibly important to deflect it away from the Earth altogether, depending on how accurate. But we already have very good, accurate tracking of asteroids as they come close to Earth. Sadly, slightly damaged by the Arecibo, which was our best radar for tracking close approach of. But we've got the Goldstone Observatory as well, which does radar tracking of asteroids. So we can have fairly precise tracking of the asteroids, and so get a pretty good idea of where they're headed in the last few days and weeks of, I'd say, approach Earth, last few days for the radar, as well as lots and lots of observations from optical methods. So anyway, so that's probably maybe more than you wanted to know, but anyway, I've quite a long video. Hopefully it will help those of you who are anxious about asteroids to realise that it's not, and just to get back to some more normal ways of leading your life, and realise that you don't need to be, because I have helped people. Some people get so terrified by these asteroid stories they're afraid to leave their house, and they may, for instance, give up college or something because they're so terrified by these totally fake asteroid stories. So please, if you got scared of any of this, then hopefully this is reassuring to you, and you realise that it's not something to be scared of. And I will add this. I add the link to all these pages I've got up here to the video description, and I'll add this video to my my article, in the article here, if you want to read it. Why you don't need to be scared of asteroids, far less scary than lightning, and that's the message that I'd like you to come away from this with.